Hello friend, it's your NOLA Mathman here for another math adventure. Unlike Superman, I cannot leap tall buildings in a single bound, and I'm not faster than a speeding bullet. But in regards to math,
Superman got nothing on me.
After watching this video, students will be able to graph and solve quadratic inequalities. The concept we're looking at is quadratic equations. The skill we're learning is graphing quadratic inequalities. So we're doing section 4.8, and with no further ado, let's get into our lesson. So we're starting by graphing each inequality. We have here a quadratic inequality of y greater than or equal to x squared minus 4x plus 4. So what we first want to do is I present to you some rules for graphing linear inequalities that you can use as a template to make it easier. So the first thing we will notice in our inequality for this particular problem, we have greater than or equal. So from that situation or that particular quadratic, with that particular linear inequality, we will determine certain things using our steps for graphing linear inequality. So the first thing it says is to transform it into slope-intercept form. It's already in slope-intercept form. It says graph the line. So at this point, what we want to do, since it's a quadratic function, we write the general form ax squared plus bx plus c. We pull out a, b, and c, which in this problem a is 1, b is -4, c is 4. We want to find our vertex of our quadratic function. So we use the formula -1 times b over 2a. We substitute the values of b and a in. We end up with -1 times -4 divided by 2 times 1. By the time we simplify that, x is going to equal 2. So our x coordinate of the vertex is equal to 2. We put that in the middle of our table, which we normally do when we try to do a table for quadratic functions. We put the x value, the vertex, in the middle. We pick two terms to the left of 2, which are 0 and 1. We put the next two integers to the right of 2, which are 3 and 4. And so now we want to get the y value of our vertex. Since x is equal to 2, we're going to take the equation, we're erasing the word so we can find y. We're going to take the equation x squared minus 4x plus 4. We're going to substitute 2 for x, and we're going to solve for y. So that's what the NOLA Mathman is going to do. We write down our x value 2, which is the x coordinate of vertex. Where x is in the quadratic, we will substitute 2 into those values. There are two values of x. We substitute 2 for the first one, that will give us 2 squared. We substitute 2 for the next one, that will give us -4 times 2, plus the 4 we had. We use our order of operation rules to simplify. 2 squared is 4, 4 minus 8 is, well, what we do, instead of going left to right, the NOLA Mathman adds the two positives, 4 and 4 is 8, 8 minus 8 is 0, so y is equal to 0, and so our vertex will be the point 2, 0. Now we look for our axis of symmetry, which we know is in the form, it's a vertical line at x equals h. H in the problem is, well, not h, we're not doing vertex form, I'm sorry. Our axis of symmetry will be our x coordinate of vertex, and since we know it's 2, axis of symmetry is x equals 2, so it's a vertical line at 2. So we plot our vertex point 2, 0. We draw that vertical line at x equals 2, and now we're going to substitute our other values of x and find our values of y, and we're going to graph those points and figure out how our shading goes, because when you have inequalities, not only do you have to graph what we call the boundary line, but you have to shade the appropriate region. So the first thing we do is we take the value of x equals 3, We substitute those values into our equation. 3 squared is 9. Negative 4 times 3 is negative 12. We will end up getting a y value of 1. So where x is 3, y is 1, which means when x is 1, which is 1 unit to the left, it has to have the same y value. Since it's symmetric and we put 1 for that, you graph those 2 points so you can see both those points are symmetric from the x equals 2 vertical line. They're both 1 unit to the left and right. So now we pick x equals 4, which we know that x equals 0 will have the same value. We actually could have picked 0 because 0 is very easy to calculate, but the NOLA Math man wanted to make it a little challenging, so he substituted 4 in. So 4 squared is 16. Negative 4 times 4 is negative 16. They are opposite, so they kind of sum to 0, and you're left with y equals 4. So when x is 4, y is 4. When x is 0, y has to be 4 too. We graph those points, we connect them, we have created our quadratic function, which represents our boundary line. But because it's an inequality, we have to figure out which way we shade the inequality. Do we shade inside of the parabola, or do we shade outside the parabola? So we're going to check it. How do you do that? Well, you pick a point, which is 0, 0. 0, 0 will be outside of the boundary graph, the actual graph. And if that range true, then we know that's the region. If it's false, then we know the region inside the parabola is the solution. So we substitute 0, 0. That's very easy to calculate. You got 0 squared is 0. Negative 4 times 0 is 0. 0 plus 4 is 4. So is 0 greater than or equal to 4? Well, the answer to that is no. And since it's no, we know that we will shade the inside of the region as the NOLA Math man is doing. And so that is our answer for the problem. We're done with number 1. So it's pretty simple. Once you pick the point, if the point works, you shade that whole region that contains that point. If the point doesn't work, you shade the other region, and that has to be the solution. And that's what we did here. So again, we want to keep the steps here to the right so we can use it to do more problems. And so now we have another problem here. We want to graph x squared minus 6x plus 9 less than or equal to 0. So again, we'll probably follow the same format we did in the first problem. We want to put our general quadratic form, the standard form, which is ax squared. Oh no, we're not doing that. Look like NOLA Math man is doing something different. Look like we're solving for x. We factored it into x minus 3 times x minus 3. We solve for x to make it equal to 0, because you see 0 on the right side of the equal sign. And so we get a x equals 0, and that will be basically our vertex value, x equals 3. Which makes sense because you want to find we call this the root. You find the value of x when y is 0. And since you have an inequality that's less than or equal to 0, that's the easiest thing to do. So at this point, we pull out our A, B, and C terms using our standard form, as I was saying earlier, before the NOLA Math man did a step ahead of us and found the roots, which was smart. And so now we want to find the vertex like we did in the last problem. The general form is -1 times b over 2a. We substitute the values of b, which is -6, and a, which is 1. We're left with -1 times -6 over 2 times 1. We do order of operation to simplify and do one step at a time, and we end up getting the value of x equals 3. So again, that's the same thing we got by figuring out the root. So we know our vertex here is on the x-axis at 3, 0. So now, like we did in the last problem, we're probably going to set up a table to get our other values. We need our axis of symmetry, and we know what our axis of symmetry, since our x value of the vertex is 3, we know the axis of symmetry is a vertical line at x equals 3. NOLA Mathman hasn't gotten to that yet. So what we're doing now is we're going to put our table. We know that our vertex point is 0, 3, 0. We want to pick 2 points to the left of 3, which are 1 and 2. We want to pick the next 2 integers to the right of 3, which are 4 and 5. That's typically the procedure and process we want to use when we want to construct our quadratic function table. And so now we'll pick either one value to the left or right of the axis of symmetry of the vertex point, and we will solve for that, and that will get us the other y value. In this case, we're using x equals 4, which is 1 unit to the right, and that will have the same y value as 1 unit to the left, which is 2. So we substitute that in. We use our order of operation rules. 4 squared is 16. Negative 6 times 4 is negative 24. We combine the like terms. We go left to right this time. 16 minus 24 is negative 9. Negative 8. Negative 8 plus 9 will give us positive 1 because they're unlike signs. We subtract. Highest number is positive, so the answer is 1. And we know the value of y when x is equal to 2 has to also equal 1 since they're symmetric. And we plot those points. We probably should have drew the axis of symmetry like we did in the first problem. I just think it's a good habit to draw your axis of symmetry before you plot your points. But I guess the NOLA Mathman is doing it different. It doesn't matter, but I think it makes it easier. So now we're going to substitute 5 into x and solve for y. And so we do that. We end up with 5 squared minus 6 times 5 plus 9. 5 squared is 25. Negative 6 times 5 is negative 30. Left to right, 25 minus 30 is negative 5 plus 9, which is 4. We know that y, when x is 5, y is 4. And when x is 1, since that's 2 units to the left, y is equal to 4. We plot the points. Now you see the axis of symmetry, which we don't necessarily have to draw, but I think it helps. As you can see, it lets you know that your quadratic function is going to be symmetric. So we connect those points. And again, now since it's a graph, a quadratic inequality, we have to test to see if we shade inside the parabola or we're going to shade outside the parabola. And so we write our general form, set e less than or equal to 0. We're going to pick x equals 3. We're going to substitute that in to see if that's true or not. And x is equal to 3. And that one is true. So what does that tell us? Let's see what that gets. What do you think that information gets us? Yeah, we didn't have y like before. We had it equal to 0. So that's why you didn't see like we did when we picked the point 0, 0. This is not less than or equal to y. This is less than or equal to 0. So we want to substitute that point. We realize that it's going to make it true. Now, do we need to substitute any other values of x to determine how to shade the inequality? Let's see. Well, we're going to pick x equals 4. We're going to try that point. We want to see if that's going to get us a value less than or equal to 0. So we substitute that in. We get 16. Negative 6 times 4 is negative 24. We combine our like terms, or we can go left to right. We've already done this before, when we were trying to calculate y. And that will get us a value of 1. 1 is not less than or equal to 0. That's false. So what does that do? What does that tell us if it's false? Does that mean we shade inside or we shade outside? Well, we're going to pick another value. This time we're going to pick 2. And we're going to substitute that in. And so we substitute 2 to see if it's less than or equal to 0. That will give us a value of -8 plus 9, which is 1. That's also false. So x equals 3 is our value that is true. Since that's the only true value, we have solved for x, and x is equal to 3. So in this problem, we don't shade it. We just get the value that makes the inequality correct. So x is equal to 3 in this particular problem. So unlike the first problem, we don't shade to determine the solution. A little different, which is good. It's good to do a variety of different type of problems. So now we're going to do a problem where we're going to solve each quadratic inequality algebraically. We solved them graphically. Now we're going to solve them algebraically. So we're going to pick one of these 6 problems and do as a group. Do together. So we have here 7 through 12. Which one do you think the NOLA Mathman is going to do? We're going to go with the first one, number 7. So we go x squared minus 3x minus 10. Now, the problem says less than 0. We're going to set equal to 0 because we want to solve it algebraically. And we factor it using the diamond method. And as you will see, it's popping up here. The product is -10. The sum is -3. We're looking for 2 terms whose product is -10. Sum is -3. Now it will be -5 and 2, because -5 times 2 is -10. -5 plus 2 is -3. That will give us the binomials of x minus 5 times x plus 2 equals 0. Using the zero product property, we set each of the binomials equal to 0 and solve for x. In the first equation, x is going to equal to 5 because you have to add 5 on both sides to get rid of -5. Second equation, you subtract 2 from both sides, x is equal to -2. And so your values are x equals 5 and x equals -2. So, are we done with the problem? Not yet. Now we have here a horizontal number line. Horizontal number lines work when we have values of x, as we do in this problem. And so we have to graph. We will go have a number line that includes both the values of -2 and 5. And so we start at -3 to the left. And again, these could go on forever. So we decide to use the values that encompass our answers for x. So we go from -3 to 6. We plot the points that we have as our solution, which is x equals -2, x equals 5. And so what do we do then? Well, I think we have to check our answers. So we got here x less than or equal to -2. So that is the region to the left of -2. And we're going to test that. So we're going to pick a value that's less than or equal to -2. We'll go with -5 because that's to the left. So I'm going to substitute -5 into our equation. That's what I surmise that the NOLA Mathman is going to do. So let's see what he does. So we're going to test again x equals -5. So let's see what the NOLA Mathman does. I would assume we'll write the equation first and substitute the values in to see if it's true. So let's see what we do. So we got here x equals -5. We write the equation for number 7, x squared minus 3x minus 10 less than 0. Okay, I was correct. So where x is, we will substitute the values of -5 for x. We will have -5 squared minus 3 times -5 minus 10, and we will test to see if that's less than 0. If it is, then it's true. So -5 squared is 25, -3 times -5 is 15. Then you bring down to negative 10. 25 plus 15 is 40. 40 minus 10 is 30. 30 is not less than 0. That is false. So that region will not be the answer less than or equal to negative 2. That region doesn't work. We have 3 possible regions. We have less than negative 2. We have the values between negative 2 and 5. And then we have x greater than 5. So we have 3 regions we're testing. So which region do you think we're going to test next? I would assume the region between negative 2 and 5. Yeah, that's what we're going to do next. So we're going to test the region between negative 2 and positive 5. And again, what we do, like we did with the last example, we will pick an integer between negative 2 and 5, and we're going to test it. What's the easiest one to test? Which one would you test? You don't have to test the exact one that the NOLA Mathman does. You could pick any one. NOLA Mathman picks 0 because 0 is very easy to calculate. That makes sense. So he substitutes 0 in. The 2 values of x, 0 squared is 0. Negative 3 times 0 is 0. You bring down negative 10. Negative 10 less than 0 is true. And so that region is a solution. So we know the region between negative 2 and 5 is going to be a solution. Now we have one more region to check. X greater than or equal to 5. So again, we have to pick a value greater than 5 or equal. We can actually use 5 if we want because 5 is equal. Or we can pick a value greater than 5. So we're going to do 10. We'll make one that's a little bigger than 5. So where x is, we will substitute the values of 10. So we will have 10 squared minus 3 times 10 minus 10, bring down to negative 10. That has to be less than 0, not equal, less than 0. 10 squared will give us 100. Negative 3 times 10 is negative 30. We bring down to negative 10. Negative 30 and negative 10 is negative 40. It's 20. 100 minus 40, is 60. 60 is not less than 0, so we know that answer is false. So our only solution is the values between negative 2 and 5. And so our final answer will be negative 2 less than or equal to x, which is less than or equal to 5. You can write it. The other notation is interval notation with the brackets, negative 2 comma 5. And so we are done, and we've learned how to solve it algebraically and test our solutions. And so we have now wrapped up another math adventure. You should be able to solve quadratic inequalities in a variety of ways, either by graphing or algebra, by using algebraic methods. And so we have had a very productive lesson, and until we meet again, it is the NOLA Mathman signing off. Have a blessed day as we attack our fears of math and conquer them as we have done today. Have a good day.